Hi guys, Mr. Thompson here with lesson 4 on electricity. This time you're going to look at something called resistance and you're going to learn how to measure it. So you should be on page 12 of the booklet. If you haven't got the booklet or you didn't print it out, it's on the web page. Your objectives are to be able to build circuits using a voltmeter in parallel and an ammeter in series, which you did last lesson, but this time you're going to use them together. And then when you take the voltmeter reading and the ammeter reading, which is the voltage and the current, you can use a formula to work out something called resistance, which is voltage divided by current. So this is what page 12 looks like. You're going to build two circuits. One circuit where you have two cells with just one bulb and an ammeter and a voltmeter, and the other circuit where you have two cells and two bulbs, one ammeter and a voltmeter. And you'll see what effect adding more bulbs in series will have on the resistance. So what is resistance? Resistance is a measure of opposition to current. So if I resist something, I try to stop it happening. That's what happened in an electric circuit. If it has a lot of resistance, it tries to slow down or oppose the amount of current. We measure it in a special unit called ohms, and it's given the Greek letter omega. You might have heard of omega clocks or omega watches. It's a Greek letter. The word ohm is somebody's surname, George Ohm, a French scientist. The larger the resistance, the smaller the current, because it's trying to oppose it more, so you get less current. And therefore, if you decrease the resistance, make it less, you'll get more current. And resistance is used in a lot of electronic circuits to limit the amount of current, to get it just the right amount. So the equation that you'll use today is resistance is voltage divided by current, where voltage is measured in volts, current is measured in amps, resistance is measured in ohms. All three are signed as voltar, ampere, and ohm. Okay, so the first circuit, you might want to pause this video now and draw this into your booklets or onto your paper. You need two cells, one bulb, one voltmeter in parallel, you can see that in parallel at the bottom with the bulb, and one in series. You're going to build that circuit, measure the current, and measure the voltage. So this is what it looks like when you build it. I deliberately haven't connected it up. You see on the bottom right corner of the circuit, it's not connected so that you can't see the values. But when you build this, you'll get a voltmeter reading at the bottom there and an ammeter reading, the current reading, and you can write those underneath the circuit on the page. And then you can use that to work out resistance. So just to remind you, the equation again, resistance is voltage divided by current. Put that in your calculator to work out the resistance and write that underneath the circuit. Remember to add the ohm sign because resistance is measured in ohms. It's an omega. Okay, so once you've done the first circuit, move on to the second circuit, which looks identical except the addition of one more bulb. And you can see that bulb is in series with the other bulb. So again, two cells, two bulbs, an ammeter and a voltmeter, and you build that circuit. So when you've built it, it looks like that. Again, I haven't connected it up. Take the voltmeter and the ammeter reading and write it on the page on your book. So you write those in, and again, a reminder, once you've written the values in, divide the voltage by the current and write down the resistance underneath. Once you've done that, you then need to have a look at the values and write a conclusion to answer these questions. What did you notice about the current when you added another bulb? Did it stay the same? Did it increase? Or did it decrease? And an effect of that, what happened to the resistance? Did it increase or decrease? And finally, what did that increase or decrease in resistance do to the brightness of the bulbs? So when you've finished that, you've written it on your page. I don't want you to photograph it and send me it. I'd like you to add your results in. If you haven't changed the values of the bulbs or the batteries, then you'll all get the same answer, so I can see you've got it right. So enter your answers into Microsoft Forms, the voltage and current for each and the resistance for each, and I will be able to see that you've been successful in your work or not. And if you haven't, then I can help you. Okay, a bit of extension work. There is in this circuit design a thing called a resistor. The black arrow is pointing to it. So try building a circuit, try adding the resistor, try changing the value of the resistor. If you click on it, you'll be able to change the value. See what happens to the brightness of the bulbs and the current in the circuit and also the voltage. So that's extension 1. You don't need to write any of this down. And circuit 2, you might want to add bulbs in parallel now instead of series, and try add more in parallel. See what happens to the current and the voltage, and therefore what happens to the resistance. Thank you for watching. If you did some extension work, please take a screenshot or screen recording and send it to me. Hopefully you've enjoyed this lesson. Thanks for listening.